coming from, what sort of columns are important for the use case that we're trying to do. So from there, I think I took the guys through just inputting the data from where it's sitting, and then we did the data exploration and a basic explanation of methodologies or things that we do to overcome some of the weaknesses. So I showed the guys a report that we generated for our input data. So it will show you if your data is skewed. It will basically take you through all your columns, show you the distribution, show you the interquartile ranges. You can do a box plot on those values, showing you the distribution and the range of your values. So basically now you can at least see if any one of the input columns that you are going to work with are not either not balanced or they need to be transformed in some way before you start doing your machine learning or training your algorithm. So the kind of sort of work we are doing here, I see there's a hand. Is it Lauren? Is the hand up or it was from before?
No, it was from before.
Okay, all right. So based on that, what we then do is, once we understand the quality of data we have, from a feature engineering point of view, we now know what we need to do. But we are using an automated way of doing most of these things. You would otherwise have had to write a lot of code to arrive at a simple model. And it might not even be as good in terms of performance. So the way we are working, we're trying to automate everything. So the EDA part, which is exploratory data analysis, we've automated this as well using the module data prep. For machine learning, we're using PyCaret. These are all automated tools that allow us, by just passing parameters, we are able to actually train our model. We're able to transform our data for the use case that we are building for. So yesterday, I think I saw two questions. I sort of thought of it afterwards. There's, I'm not sure who it was who mentioned airflow. There was someone who mentioned airflow, I think, when we were having the questions right towards the end. I don't know if they're on the call now or they're not.
Yeah, it was me.
Okay, was it Moses?
Yes.
Okay, yeah, so airflow is quite different. Airflow is quite different. Farai, are you on the call? Farai? Farai? All right. I'm sure you are experienced in Airflow. Airflow essentially it's an ETL orchestration tool that runs still on a Python base. This is quite different. I think MLflow is different because that's specifically for machine learning, for your for monitoring your machine learning models, for serving your inference from a machine learning model point of view. So it's quite different from Airflow. I thought about it later. When you mentioned it, I didn't quite think about it at that point. So the way we are just going to quickly continue from where we left off. There were quite a few questions around certain things that we had not done in our setup. So for instance, I did mention some of these things in passing. So you might find, if you compare the files that I shared with you yesterday, they were basic commands. We're just normalizing and transforming and ignoring the low variance ones. We were not doing anything around specifying numeric features. So what might happen, remember, when because we've got our data frame, the data right at the top there, when we do our setup, it will try to infer the data types that are in your data frame, and sometimes it might miss certain values. It's based on like its own inference. It will scan, I think, about 50 first records, and it will try and say, okay, this must be a category, this must be a numeric feature. But sometimes you might actually want to enforce to then say, no, employee count is actually a numeric because it's 1, 1, 1, 1, 1, 1. So I want it to be numeric. There's nothing categoric about that. So this is one of the things that I've now done to just enhance our model. And I've specified a couple of other columns that I saw were being declared as categoric, but they're actually numerics. From there, the only other thing that I did, I went for numeric imputation. So remember, we're talking about now values and how do we then handle those values. So we do an imputation by passing the mean. So I will show you the data. I think we've seen the data before. I'll show you the data after now to say, when PyCaret is doing this automated way, what exactly is it doing to our data frame when it then transforms it? Categoric imputation, I think we spoke about it, we're implementing it here. Fixed imbalance, I think somebody had raised this question in our meeting yesterday. I've put it here as well. For the ordinal features, I think we spoke about it. So ordinal features, we've got a column called business travel that has got these texts. So if you remember what I was saying, that sometimes it's not necessary for it to transpose all the columns. You might want to just have a 0, 1, and a 2 to represent these three, because I think those are the only possible columns, values from our column. So we might as well not transpose it, but within it, replace where it says travel rarely, put a 0. Where you see travel frequently, put a 1. Where you see a non-travel, put a 2. So it's just a way, because remember, our machine learning models, they all work on numerics. You will not put a string value in there and expect to get a model that works. So from there, I think that those are the only things that I added. And if we go right to the bottom, you can see now the fixing of imbalance is now true, and it's using SMOT. We did speak about SMOT yesterday. Just gonna go down to the bottom. So to get the transformations that have been done to our data frame, we will call another PyCaret function, which is called sorry, this is not correct. It's actually supposed to be getX. So it will just go and get the configuration and put it into a data frame. So I've created another data frame now, where I'm saying before, this is how my data was. After it's been transformed by us passing in these parameters, how does it look now? So if I do a head command will just say, give me the first 5 rows of that data. You can see age, everything. So if you look, remember, we're also normalizing our data. You can see age has been normalized. Nothing much has been done to it. It's just been normalized. So remember the normalization, we're saying if you've got 10, 20, 30, it will probably do a 0.1, 0.2, 0.3. The value or the significance of the value does not change, but you've compressed your space in terms of the numeric that you are passing to your model. So that's what PyCaret has done. The only other thing maybe that I can go to quickly would be, if we look right, I'm gonna look for something. So look at department. If you look at department, we have department as one column. Now it's saying department underscore human resources. So if someone belongs to the department research and development, it's only on research and development where it will put that 1. Everything else under department will become 0. So it's basically transformed it into columns, and for each and every one of the values, it will just go and put a 1 where the value is applicable. Similarly, on education, you can see you've got education 1, 2, 3, 4. So these were values that were in the education field only, and it was 1, 2, 3, 4. So this is one hot encoding. I think we did speak about it yesterday, where we are basically transposing our columns, our rows into one column into multiple columns, but based on the values that are in there. But we maintain the content of the data. We're not really changing it. But this is the way that we will transpose our data to actually work for machine learning. You would have had to actually write your own code and go and say, I think I did mention that command is called get dummies, and then you would pass the column. So you would have to then say for columns in We will provide a list of education, what was the other column, department. If the column is in this, go and run a get dummy on that column, and then it will transform. But we've simply just told it that transpose our data. We've just told it to go and do transformations on our data, and it basically does that for us. It's just by passing one column, and it goes and do that for us. Am I on the right column? I don't know if there's anything else that I could show you here. Trying to see. So that's basically what our data frame looks like. So similar to what we did with the original data set, I've also created a report of the transformed data so that at least we just visually see the differences. So if I'm here, this was our original report. In our original report from the original data frame, we had 35 variables. Now, after the transformation, you can see we now have 74. But this data set now is much more cleaner. You might still find certain values that would still remain skewed because of the nature of the data that is in there. There's nothing much that we can do, but at least it will show you where it has gone and changed, where it has sort of replaced nows, where the values have been transformed to sort of look better for machine learning. If we go to, we are on age now, the original numbers would have been like this. So you can see we actually had the actual values, which was 18. Our interquartile range was 13, but it has compressed those numbers. You can see the numbers are still the same. Our sort of they've been normalized, but the interquartile range is now 1.3, but the content itself does not really change. So all of this, by us using PyCaret, it means it has taken care of the heavy lifting that we would have had to do by us going to write all this code and sort of waste a bit of time doing that. I don't know if you want to call it waste time, but it might take a bit of time to get around these things. So this, I think I just saved the report. That's the report that we got. So based on the changes that we did now, so remember in the past, we had not told it to do a lot of things like balancing our data, fixing the imbalances, taking care of the now numerics and all of that. When we now compare again, remember linear distribution, LDA was, actually it was logistic regression that was leading yesterday. Now, all of a sudden, logistic regression is on number 4 in terms of area under the curve. So you can see the difference that it makes in terms of taking care of your data. If we had run the data like that with the nows not taking care of the nows, we would have gone ahead with this model and we say logistic regression is the best performing. So by simply having the comparison from what we did yesterday without having taken care of our features, you can see the huge difference that it makes on our model. So this is where there is still a bit of an art in terms of a data scientist knowing their craft and doing the work they need to be doing. So automated tools are still there, they will guide you, but it waits for you to give it the parameters. If you don't tell it to handle imbalance, it will just give you a model and you can go and work with that model. It would look like everything is fine. I don't know if there are questions there before we proceed.
Not for me.
So is PyCaret primarily almost like a data cleaning and standardization? No. What would you
does? It does that and more. So remember, the data cleaning is just one part. That's the same sort of module that we are using to create the actual models. So it's not just on the cleaning, but it's covering the end-to-end of our machine learning process. We want to clean the data. We then want to evaluate our model. We want to create the model, evaluate, and then serve from there. So it does everything. in a typical ML sort of project, you would have to write, it would be specific steps that you would do to do all of those things.
That was my question to him yesterday, Tendai.
Oh,
I
sorry.
asked him the question.
Okay, so it's primarily an automation. We can rather call it an automation.
It's an automated. So it falls under the category of automated machine learning tools.
Okay.
So there are quite a number of them. I think one of the popular one is called AutoML. I haven't really used it much, but there are quite a lot of them. Amazon has got they've got one in SageMaker, where all you do on in Amazon, you put your data in an S3 bucket. If you go in SageMaker, it can actually create a model for you and do the same thing that we're doing. But with Amazon, remember, you have to then pay a bit to run these things. So we are fortunate enough to have compute time, where if you can run it on your machine and actually get your work done, you would rather do that than to be spinning up instances in the cloud all the time and then end up getting a heavy bill. So maybe that's a side issue, but yeah.
Okay, thanks.
Sure. Right. So that was that. So the other thing that I did is, so remember, PyCaret will come with its own with its own module. So it's based on what is called scikit-learn. So scikit-learn is one of the. I remember we were talking about me jumping around. Should I not move, right?
I don't know.
It's fine.
It's fine.
So scikit-learn is one. It's the base of what we are using. What PyCaret uses. So they've got a whole list of algorithms that they use. If you look at the algorithms, it's quite a long list. So you'll find what will happen now. PyCaret will go and just bring us those algorithms that are default in scikit-learn, but you can use it with any other algorithms that are not part of scikit-learn. So there's a popular one called XGBoost. These are things that you should probably research more and read around. How does it work? What is XGBoost? So maybe let me not go here. This is a course. I want to go here. So you can go and read the docs. They will explain what it is, how it works, how it actually does training. So here, I think they've given us different options in terms of where you can work with it from. I actually did the same exercise because that was the whole point of why I was saying install PyCaret full, because I knew it would bring XGBoost. But with the issues that we were having yesterday, I then went ahead and created it on the side. Let me just see. So based on the models that we've got today, we see that GBC is the one that is performing the best. I then went ahead and created a model. So yesterday we had logistic regression. Today it's now GBC. So we go and we tell it, create a model on GBC, use 10 maximum depth. So we did speak about this yesterday in terms of the cycles that it would go training. From there, I've got my model, but I've said I want to bring another model into PyCaret, which is currently not installed on my machine. So I'm the XGB classifier from XGBoost, and then I do the same thing. The same way I would create the model here from our PyCaret. I'm going to say, go and create for me XGB. I want to be able to compare that one and the one that's currently sitting in PyCaret. Similarly, like we did yesterday, we tuned the model. If you are going to tune an external model, you need to provide a parameter. So it's the same thing: max depth, number of estimators. Those are parameters that it requires. But you'll find if you go to any of the documentation, it will actually give you a whole list of parameters that you can pass to the algorithms as you're training your model. From there, let's see, did we do this one today? Yes, so I did the same exercise like we did yesterday, just to look at the performance to then say, look, in as much as we have refined our data, are we getting better performance based on us doing that? So the same graphs, I think yesterday, will this work today? Okay, I haven't run it, so it won't work. If we run this, we are then able to view the evaluation of our model versus the training data set. So training and cross-validation, I think those are some of the things that I crossed over yesterday. Generally, what happens when you are pushing your data for training, you would probably generally say give it 80% of your data for training, and then you've got a holdout set, which is the 20% that you then say, look, I don't want to pass everything to this model for training. I want to then verify with another 20% afterwards. So when it is trained, you then pass the way it then evaluates, it then says, okay, so how well does the model that has been trained on the 80% of the data perform on this 20%? So that's how it then judges the performance of your model, which is when you're now in production, you are actually giving it new data that it has not seen before. But for training, PyCaret is also handling that for us. We would have had to go and specify the parameters to say the split for training and validation is, so you could say maybe 0.7 is for training, and then it would default to the 0.3 to evaluation. But because it's an automated tool, it handles all of that for us without us having to worry. But you need to at least have the knowledge that that's what happens. You want to avoid training on the data, and then you think your performance is very good when you have not evaluated with unseen data. Generally, you're just setting up yourself for failure if you do something like that. So I did the same for the one that we trained, that we brought outside of PyCaret as well, the XGBoost, and I was able to get the, I think this is where I got stuck before I was kicked out. But in any case, I submitted my model today, and then I did my predictions. And the predictions, I then say, show me the first 20 rows in the data set. I can't see how far you can see. So in our original data set, we were only ending on years with current manager. These are the two columns that are brought in. I don't know if I can highlight. You can see that, yes. These are the two columns. So these two, they are brought in by our model. So when it did the prediction, it then says, I'm predicting no for this first line. Maybe to make it make sense, let me do this.
At the columns you're talking about label and score.
Yes, label and score, yes.
Okay.
Label and score. Let me do this. So that it's a bit easier to consume. Let's take employee number. Let's take attrition. So remember from our original data set, attrition was our target column because that's the one we got from our company. They told us that this person actually left the organization. So we used that now to train our model. And let me just do this. Right. Sorry, I'm not running this in real time. I won't be able to show you these results. Okay. Anyway, we'll explain it better. I thought I was running it in real time. I could still do that.
But,
okay.
But we are following the edit first column.
Yeah. But it's fine. We'll do it. I'll leave it here. When I share you with the file with you, you'll be able to see that. But essentially, what it has done now, it has said. So if you look at line number 1, there's a no, yes, and the score is saying this is the probability or the confidence in that prediction. So if it's saying no and it's saying 0.83, that's very close to 1. So that's like 83%. The model is saying I'm 83% sure that this is a no. Here it's saying 0.5, that it's a no. So remember, we're talking about the perfect signs where we know that if you put in money, it's going to be so much in 10 years based on a straight formula. This now is more around probabilities and degrees of certainty. We are not sure, but this is what we are saying. So having some of these things now is what then empowers us to then say, okay, if we are to make a decision or to make a call, how sure are we about that? So let's look at the first two. It's 50% and 83% on a no. It was actually yes and no. So you can see here, it got confused somewhere, which means the features that we gave it, it wasn't able, it wasn't so sure that this is actually a no. But where it was a bit sure, you can see it's actually a no, but the probability is higher. So this is where we then play in data science. So the evaluation that we're doing is to get us to that point where we're then saying, look, if we've got 10,000 records and we miss, let's say our model misses 20, is that good enough? So you now as an organization, or maybe as a data scientist, you'll probably have in your organization some rules that have been set up to then say, guys, for our performance in this organization, this is the bare minimum. If your model is performing at least at 90%, we can live with it. If it's beyond that, we need to retrain, or let's relook at everything that you've done. So that's where now we're getting now into that monitoring and evaluation, because your model is going to be out there now. You are running predictions in real time. If you keep getting degrading performance, you need to have something that you're monitoring now to then say, look, my model is probably getting to 85%. That's below the threshold that has been set. So something needs to happen. Either automatically you retrain. If you're using a mature system, right now we're working in a notebook, so this is just a step-by-step way of doing it. In a mature system, let's say you are working on either Google or you're on AWS, you would have a pipeline that is already set up. As soon as a metric goes down to a certain level, it knows I need to retrain the model. Once it has retrained the model, it does not automatically deploy that to production. What it will do is it will do what we call A/B deployment, where it's like it will get, let's say, it will say in the A, continue giving it 80% of the data, test another 20% with this new model. Let's see how well it's performing. So it's like an election where one candidate then comes and they say, I think I am better than this politician. This one has been stealing your money. He has been doing 1, 2, 3, 4. I'm better. I'm more efficient. I'm 1, 2, 3, 4. And then they said, let's try it out. You see which one performs better. As soon as this one shows that they are better, they are elected to be the president. That other model now is all automatically taken out. So that's where MLflow now comes in as well. Because remember, you're logging the performance of your model over time. So you've got to have something that's keeping track of what's happening there. As soon as the performance goes down, you don't want to manually again go and retrain. You must have a mature process in place now that can automatically train these things. But obviously there's human intervention. You approve some of these things and. So that is the reason why we're speaking around the evaluation, so that at least you get to understand. But it's good to see that even it's not a perfect science. Where it says, I'm saying no, but I'm 50% confident. You can clearly see it was a yes, but it happens that I might have the same features with someone else who actually lives, but it doesn't mean I'm gonna leave. It happens. But this is where the science now comes in to then say, based on what we have learned and the predictions we are getting, is this model good enough for us to get results from? Are we together there?
Yes.
I see a thumbs up. I see a thumbs up. All right.
Yeah.
So what I've done now is I outputted these predictions into CSV again. I put them in my data process, predictions, HRI, and then I've got my timestamp there into CSV. So if you are in the marketing space, this is probably where you now need to upload this onto your CRM system, or you send it out to your business partners, depending on what you're doing. So you can imagine if you were dealing with maybe data that is open source, you could actually set up your own project in the cloud and start, giving your potential clients or maybe clients such insights based on information that you can source, say, from the cloud or the cloud, or for things like this. I used to do stuff around social media monitoring. So if you look, like recently, I think we've had issues with the lootings, and I think there's been a question around intelligence. Was the intelligence really there? Was it not there? Those kind of things. And I overheard the minister saying that sometimes what would happen is they were getting information that there's something happening at a particular place, and then they would all rush there, and then they get there, they see there's nothing. So what's happening in the back end? Is it really intelligence, or something is just, how do you collaborate, this kind of thing? So this could be a potential area maybe for someone who's interested in these things, where the information is already out there in the cloud. You can create a product where you can start aggregating these things over time, and you approach someone and say, I see you're struggling with these kind of things. I can give you this information, and you can actually better your decisions. It's just a thought. I'm not saying get into politics for those that are not in politics. All right, so I did save the model as well, like we were doing yesterday, and outputted that model. There was something else that I wanted to talk to you about that I did today. I don't know where I missed it. It was around logs. Around logs is probably somewhere here. Let me see, where is that? Sorry, let me just do a search. All right, there we go. So there was someone, I think I'm not sure who it was asking in terms of, so what is PyCaret actually doing? I mean, PyCaret and MLflow, when we say log our experiments, when we say log experiments equals to true, where exactly is it pushing these things? So this is just a sample of what it does. It will have a run ID to give you a status. It shows you exactly where the artifact's URL is, in terms of where it's storing the artifact, when did it start and when did it finish, what was the performance of our model on each one of these metrics. So this is the information that gets passed now to what? To MLflow. The parameters that we passed to our model, it will record all of that. What else? It will show us also the target. So this is just a run ID. Who is the user? So basically, you can see it shows us which sort of command actually got us to get, was initiated for us to get this log. So this is where all the parameters are going in terms of how PyCaret now would communicate with the MLflow. So MLflow, all it needs to know is to know where the URL for these logs are, and then it will give us a nice visual where we can interact with it. So that was that for yesterday. Now, for the work that I had planned for today was to then say, if we've gone through this journey, we've trained our model, we've got predictions, how do we then communicate that to our business? I've seen a lot of models that end up in IT, and you never get a result that goes out. And people are forever building models, but you never really see what are they doing. So what I did for this project, I set up an environment for doing visualization. So visualizations is one way. The output from your model could be notifications. It could be you could be pushing your results into a streaming platform, and then it gets consumed by other platforms. What I did is I created an environment that we can use to create dashboards. So I've put in even the procedures of how I created that environment. I think once you see it, we can always go back in terms of how to create it. But this is, if anyone is interested in any free BI tool that they can host themselves in the cloud and at least get some data out. From here, what I did, maybe let me start here. So I'm using Horeku. Horeku is, they provide free access, I think, for a year. So I took advantage of that. And that's where I set up our project for doing the visualizations now, to then say, yes, we've got the predictions. How do we then communicate what we've got. Come on, why is it taking time? I think my machine was sleeping. Whilst it's coming up, I will explain what I did. Okay, it looks like it's up now. So these are the commands that I use to set up this environment. If anyone wants to try it out, I'll share the link to this GitHub repo, and you can create your own environment. You're able to actually get a BI tool up and working. The only thing I've got is in my Horeco environment, I've got a Postgres database which stores the files. So our CSV file, what we'll do is we will go and upload. So I've already done that when I uploaded the file from our results, but you could have some ETL process that runs and it dumps your output into some database, and then you just connect to that database. From there, the next thing that I did now was to create a data set. Let me just move these things. So I've got a data set that I created. You can see this was done 5 hours ago. If I come here, I'm actually visualizing it, but I don't want to start doing that. Let me start by just showing you what it's doing at the back end. So this is all 100% free. You do not pay for this for Superset. Superset is an open source project from, I think it's an Airbnb project. So similarly, MLflow is from Databricks. So a lot of these companies, they would run some projects and then they open source some of the things, and you can find actually good value from there. So this is the database. I just created a SkillX DB. The columns, you can see these are the columns that are in our file, but we've got two new guys, the label and the score. And then what I then did is I just did a simple calculation here. What I said is, okay, I've got the score, but I want to apply some aggregation around that to then say, if my score is above 0.7, I'm gonna say the risk is high. If the score is above 0.5, it's medium. Otherwise, it's low. So this then you are now getting into the analytics space now, where you're then saying, how else do you aggregate your data for visualizing it? The other one, I think I just made sure, because we have got yeses and nos, I want to use this for sorting. So you can then enhance your data in terms of the columns that you get from your prediction. You could do more around it to at least give you better visualizations. So from here, this tool allows us to create charts that we can do on the fly. The basics of it is, I'm gonna pick maybe something that I didn't use before. Let me look for maybe gender. I never did anything around gender. So if I come here and I say run this query, what it's gonna do is gonna split the gender by female, male, and then I'll say, okay, I'm not interested in a table. Can you please show me this data in a pie? And then I run again, it gives me a pie. Then I say, okay, I want to customize that pie. Let's make it a donut chart. Okay, I see let's make it a donut chart. Just enhance this a bit, maybe to look like that. So you see how quick and easy it is to create sort of visualizations with this. I'll say save it as that. And we do that. So I've already created a chart that I can use to communicate to my users, to my business users. From there, the next thing I'm going to do is, once I've done all the charts, remember, we have business questions that we're trying to answer. We said they want to understand, let's say, if someone is leaving, what are the contributing factors, or from which is distance an issue in terms of most of the people that are living? Is it monthly income? How do you then say, look, I've got these predictions from your data, and from what I'm seeing, this is what I can communicate back to you. So from there, I created a dashboard. I will show you also how to do that. This one, you forgive me, the visualizations might not be the best, but at least for bringing out the use case in terms of what we want to communicate, you can see something there. So I've got a filter here that says the risk, that says the label. So this one targets the table at the bottom. So in the table at the bottom, we've got the detail now to then say this employee is employee number 65. In the original data, they were a yes, and our prediction is actually saying they are yes, and the confidence thereof is that. And then you start showing all the related columns, because at the end of the day, this is what you then want to communicate to your business users. And then you're saying for everyone, based on the full data set that you got predictions of yeses. They were 178, and 1.2K were no's. And then based on that category, remember we're talking around, we created this column now after we've run the model. We can see that the high risks are 70%. They are for where the prediction is a yes, the bulk of them are already really in that high range. There's quite a few that are within the 50%. So this, I think, gives you a picture in terms of based on those 178, how bad is it really in terms of those that might leave. And then from there, you might then say, okay, maybe I don't want to just see the high ones. If you are interested in the low, to then target the table at the bottom, it then shows you all of those things. The split by income and education. So you can see there it says medical, the average income is 6.8. So this were in US dollars, 6.8, and it's 16%. Marketing, for those that left, it's 7.5. So this now is to try and get you to a point where you are then saying, based on my prediction, what can I pick out to say is the issue? Is it money? Is it travel, distance from home? Is it education? Or is it people that have stayed too long in one role and they feel like they're not getting an improvement in their career? Similarly here, I'd say it's more of the same view, but just a different with bubble charts to just show you based on that to say for sales, marketing department, sorry, this is education. Sorry, this is education. If someone is educated in sales, oh, did I do it wrong? Maybe I did. Probably did it wrong. I probably put department there. What is the average monthly salary and how many of the sales and marketing people are in that space? So this shows you your distribution. You've got one person there who's definitely an outlier and they were earning sorry, the average monthly income is 2.1. So where do you focus your energies on based on what you see? And to do this, creating the dashboard is quite easy. All you do, remember we've created a chart. If I say I'm just going to do something, I shouldn't do it, but let me just push something here so that at least we can demonstrate how this works. I'm going to look for that gender distribution. If it makes sense to put it there, for instance, you see how easy it is. All you then do is you drag your charts onto the plane and you've got your dashboard out. And then for the filters, all you do is you come and you tell it, on my filters, the risk one, just double target the table only. The label one, do the same, target the table only. If you want to target any one of the graphs, you just tick it here and then it targets the graph based on what you're doing. So I'm quite open to share access to this particular instance if anyone wants to play with it. You can communicate via Tendai. What we'll do is we'll probably just create a user, which is probably, let's say, your initial and surname. If you want to go in there, the data is already loaded. You can play with the data set that is loaded already there. Nobody's paying for this. There is no personal information here, so there's no issues here. Are there questions?
Not yet, but I'm seeing a hand from Moses.
Okay.
Yes, yeah, lovely presentation, eh? On the visualizations there, how is it refreshing the data? Because remember, we're doing batch scoring. So it means that we have intervals that we need to refresh the data so that it's updated on the app. How is it doing that? Or can the app be linked to a database?
Yes.
Maybe a staging database that we have in the pipeline, which simply pulls the data at a certain interval.
Okay, yes. So Superset, what it does is it's got rules that you can give it to tell it when to refresh. So it's like a cron job. You can tell it when to refresh. So for instance, if you're doing something daily, you could tell it to refresh every hour or every 2 hours or every morning at a particular point in time. It's all based on the rules that you would set. And then in terms of databases, probably what I should have done is to give you more detail around how many databases you can connect. Let me just do this. Come on. Sorry. Okay, so this instance, I can't choose that database, or can I see? Okay. Sorry, this one I can't see. So this one is just working with the URI, but there is no limitation in terms of the number of databases you can connect to. So if I show you my connection details for this one, I don't mind showing you exactly where it's connecting. So I've got, it's sitting in AWS. It's an EC2 instance sitting in AWS. So this is connecting to a database that is sitting in the cloud. So it's not really in Heroku. Heroku is just hosting the app. The database is actually sitting in AWS. All I do is I provide the connection details, and then I'm able to connect to it. So similarly, if you're running, let's say, MongoDB somewhere where at least you can access it, whether it's sitting behind the file or not, those are things that you then have to consider in terms of your design. But you can connect to almost any database that SQL Alchemy can connect to. So your Oracles, SQL, this is a Postgres, MySQL, for Hadoop, your Hive databases. I think, yeah, the limitations, I think you are not limited, in terms of the database that you can connect to. And then for the refreshing itself, there are settings that you can set in terms of, sorry, let me just do this. I wanted to open it. Okay. Let me just do that. So here, you see, you tell it how often do you want to refresh. So if you're running a process in the back that's loading your database, I'm sure you would know how frequent you're doing that. It would auto refresh. But the good thing about this tool as well is it does cache the results within a Redis instance. So it means if you've got so many users that are hitting your dashboard and nothing has changed in the last, say, 24 hours, you're not going to run a query again to the backend. You're just going to get served from the cache. So it makes it a bit faster.
Then my next question was, so this whole pipeline, let's say we take it as a pipeline. What can we use in the backend to actually run the whole pipeline? Because now I see there are pieces, the front end, this piece, which is the front end. There's another piece that's running Postgres.
Yes.
Then we have the Python scripts that are doing the modeling. How best can we run this whole pipeline?
Right. So here now you are getting more into ML ops now. So ML ops is you're concerned about the running of the whole pipeline, and then you say, my hands are off, let this thing run. You need to think about where is your data going to sit. So for instance, one, I would say go with, let's say AWS. You use AWS to stage your data into an S3 bucket. Once it hits an S3 bucket, the S3 bucket knows that you set an alert on that bucket. It kicks off a Python job. So remember, what we are doing here, we were training all the way from the start. If we are now at this point where our model is done, if we push data into a bucket that is a production bucket for results inference. It knows that I need to run a particular job for inferring results. It then kicks off a pipeline. Maybe if you don't mind, I can show something to explain better what I mean. I'm trying to look for something that I did recently. Okay, so I did this. This was on AWS. So what I did is I created a pipeline where I use what are called step functions. So step functions, essentially, you are trying to break these chunks that we're talking about. You've got something that is concerned about predicting. You've got something that is concerned about training. You've got something that is concerned about where do I put the output of what has been trained. So you create functions that are called in sequence one after the other. So for training, typically the way we've done it, the exploratory way, we're going to tweak and play around with things. That's how you would normally do it. But once you have got your model, or you've got a way that you've said, look, for me to train anything in this space, this is the code that I'm going to use. You would then create a pipeline, sort of maybe a file that just handles training, which means everything else that we're doing in terms of evaluating, and you take all of that out. All you do is you're concerned about get the data, pass it this parameter, train the model, give me, write the output to MLflow. You are not doing all those things that we're doing, the EDA and doing evaluations and all of that. So that then becomes, it's like you're coming and you're saying in this Python script, take out everything from the top here, do the importations, get the data from where it's coming from. Everything that we're doing here around looking at the columns is not important. So your job is now specific to say, this is the script that trains my model. All it does is you import your module that you use for training. You set up the job. It does your training. You create the model, and then it outputs the model. And then now at that point, if it's done its job, the model is outputted into the artifacts location with a different date and different number. And that process now of then saying, which model is the best based on what you're doing? If you're doing that A/B deployment, that then kicks off. But from a step-by-step sort of way of doing it now, you then have, let's say, something like this. So this is a training job. So you can see it starts, it does transformation. So in AWS, they've got a tool they call Glue. So Glue essentially runs your Python or Spark code. So it will do your data transformation, generates a unique name. So this is specific to what it does in AWS. Do the hyperparameter tuning, run another step that does the best model path, and then query the training result. The inference rules are run from there, and then if you need to do an update on the API workflow, it does that. So you can see this is now a modular way of them saying, if you are now training, this is how you're going to do it. If you are doing your scoring, it does the same thing. So we're doing batch scoring like in us now. All we're doing is we know we've got the model already that we've saved as, I think it's, why am I reconnecting now? That we have saved as, for instance, this one is our candidate, and this is the model that has been deployed for us to save results from. It will go and generate a unique name for that, and then it does the batch scoring. Batch scoring, essentially what it's doing is going to say, go and load that model. If it's not already sort of deployed at an interface. So if you are deploying, if it's deployed at an interface, it means there's already a Docker machine that is hosting this code. It's waiting. If you push a real-time stream with all those columns, it will give you a result to say yes or no, this person is likely to leave. Or you do it a batch. In this case, it's a batch, and then it renames, because what you do is to push the files back now to your location where you say, remember when you're creating those folders, in AWS, it will be in an S3 bucket. Similarly, if you're working with Microsoft, it will be in their storage layer as well. So it doesn't really matter which sort of platform you're using, but the way it will then execute that is in steps. And you now just go back and rewrite another script where we're saying we're not interested in all that is happening. What I want to do is, if I'm on this batch loading, I want to import. I just want to come and import PyCaret, and then once I've imported PyCaret, if I load my model, the one that is currently in production. So if it's a real-time interface, it then means you don't really need to load it. It's already an interface that you know. All you do is you call that interface. From there, I want to get my data. Data equals to, I don't know if you've got a new data set that you want to read. You read a new data frame. I'm going to assume you're reading from CSV, and then you specify where the data is coming from. What is the next thing? The next thing I'm predicting. I don't even need to worry about everything else. From there, I get my results. Predictions equals to predict. So remember, the model is already loaded. We're predicting with this model and our data set. And from there, we save the result. The same thing. Predict. I don't know if someone is talking, or maybe I'm getting feedback.
All right. Yeah, this part. Yeah, I'm getting this one.
Yeah. So yeah.
So with PyCaret there on the model there, when you create a pickle file, it automatically creates artifacts of the transformations, the balancing, the imputations, the scaling, the normalization, all those things. All right.
Yes. So I think that's where I was showing you the logs. Remember when I went to the logs? Yes. So it stores everything there.
Okay. Yeah. All right. Thank you.
Any questions?
No, not for me.
Not from you. Who thinks they are ready to go and do some development now?
I'm pretty ready. I'm just keen on doing the practical side by myself.
Okay. Yeah, let me remember to remove these things, otherwise. Okay. So I think for me, that's the journey that I wanted to take you guys through, and just show you something from an end to end, where we start off with just the data file. We go through the process in terms of how do you work with the data, how do you choose a model to work with, and you understand exactly what it does when it actually does the prediction. You get those two columns. How do you then use that to communicate something back to business? So that's, I think, what I wanted to do with you guys. I don't know if there is, I see on the chat. Okay. All right, we're good. If there's no question, it means we're all happy. We can close the meeting.
Wait, before the meeting is closed, I know the video is gonna be put up, but will we also be receiving the instructions from today for our own practicals, so that we can do it by ourselves?
Tendai?
Yeah. I think it's still more up to you. Maybe to say, I suppose, because we've looked at quite a few tools, right? So are you talking about to say that, okay, first step, you're doing this, and then you use this tool?
Yeah.
Okay.
Like on the first day, we had the video, right? But then there was also like a PDF with the commands, like the codes and everything, and also definitions within it. So is it possible to receive something similar from yesterday's session and today's session as well? Because I feel like we've done a lot of theory, which is really great, and that's where we should start. But for some of us, we learn by doing, so practice. So is it possible to get a similar document like the one we got on the first day, so we can do the practicals by ourselves, and then we come back to you where we have glitches.
Yeah, I will send my notebook so you are able to work with that one. It's got all the commands and the notes in between as well. But if today you keep that group open, right?
Yeah, it's open forever. Yeah.
Okay, all right. Then yeah, if there are questions, I'm sure you can reach me through that, and then we can always take it. But it should be fairly simple to go through this.
All right.
Awesome. Thank you.
Okay, cool. So do you need a couple of days, Langton, or?
Yeah, because it doesn't have to be immediate.
Yeah. I can just
Uh,
post the
or-
video, and then when you have a bit of time, then you can
Yeah,
okay.
it's fine.
All right.
Yeah.
Cool. So guys, just join the group on skillx.africa. If you have issues, you remember the phone number. Does anyone not have the phone number?
Yes.
You don't have the phone number.
No, sorry, it was breaking. I thought you asked, does everyone have the number?
Okay, all right. So just make sure you've got the phone number. So if you've got any issues, then you can just send a WhatsApp, then we'll try and help you, okay?
All right.
Okay, thanks so much.
Sorry,
Yeah.
can you share the phone number? I actually don't have it.
All right,
Can you just type it.
I'm putting it into the chat now.
All right.
In case anyone needs.
So thank you, Langton, for this thing.
Sure. You're welcome. You're welcome.
You can back.
You're welcome.
Thanks, Langton.
Great, guys. It's been fun. I've learned a lot from you as well whilst we're on the chat. I look forward to seeing more data scientists very soon.
I think definitely. Thanks so much. I think, Langton, like we can see how much of preparation went into this, and the passion you have for data science is kind of contagious. Yeah, at least I kind of feel like I know where to start. I'll try and follow again, like what Tsitsi's suggesting. But I really think this was quite awesome and really appreciate your effort. And thank you guys so much for participating so well and being interactive, because it always helps if you actually, if your audience actually interacts with the content, then you know that it's working. So you guys were all awesome. Thank you.
Thank you.
All right.
Cheers.
And
Cheers.
yeah, don't forget to spread the word. Let's get to more people. Eh?
Okay.
Yeah, and let me know what topics you want to cover next.
All right.
All right, cool.
Bye,
Good night. Okay.
Good night, everyone.
Thanks for organizing, and thanks everyone. Cheers.
Oh, pleasure. Good.
Bye.
Shingi?